Hey everyone, so today we're going to learn about two more very important data types in Python, lists and tuples. So a list is a type of data structure that represents an ordered sequence of values. And the same value may occur more than once at a different position in the list. And what do I mean by ordered? Well, it means that every value in a list is located at a certain position in the list, which you can access using the corresponding index for that position. So it means that these lists are indexed. And it's very important to note that the lists are also zero indexed, which means the first position of the list is at index 0. These indices also allow you to change a value at a given index or remove a value from a certain index and so on. And this process of changing or removing or adding to a certain list is known as mutation. In other words, lists are mutable. So let's see how all this works in Python. So if I want to create a new list, I just need to create a variable and we'll call it a list. And I'm going to set it equal to an empty list, which uses empty brackets. And really the notation for a list in Python is the brackets, and that represents the data structure of a list. And so right now, if I just print the empty list, I will of course get an empty list back. And remember that the elements in a list are indexed by the position. So right now, this list is empty. And if I try and print what's in the first element in the list, which is at the 0th position, the compiler, or the Python compiler, is going to throw an error saying that the index is out of range. And as we see that, it says in line 10, there's an index error, list index out of range. And that's, again, because nothing right now is in the list. But if I just want to add to the list, I can do that using the method append. And let's just add the integer 1. And so now if I print the first element in the list, I get 1. And yeah, so let's go ahead and add some more elements to the list. And now if I just print the list, we're going to see all these elements. So right now we have a list with 5 elements in it, and it's the integers 1 through 5. And again, if I want to print what's at the first position, I will get the 1. And if I want to print, let's say, what's at the third position, which is at index 2, because 0 index, then we get 3, as we should. And like I said, lists are mutable, meaning that you can change values at a given index. And so we can do that by saying, a list, which is our current list. Let's say we want to change the second element in the list from being a 2 to a negative 2. And so now when I print a list, we see that the 2 has changed to a negative 2 because I said, all right, at index 1, which is position 2, I want to have a negative 2 now. And that's what happened. And that's the process of mutation. We can also very easily check the length of a list by using a built-in method called len. And we can just call that on the list. And if we print that, we should get 5, which we do. So there are two primary ways to remove an element from a list. If you want to remove based on position, you can do so by using a built-in method called pop. And so I can say a list.pop. Well, if I pass in nothing, actually, it will pop the last element in the list. But if I want to say something specific, like let's pop the first element in the list. Now, if I print a list, the 1 should be gone. And that's what happens. Now the list only has 4 elements, and the first element is the negative 2. We can also remove elements based on value. So if I want to remove, let's say that I want to get rid of the 4, then I can say a list.remove 4. And now if I print a list, we only have 3 elements, and it's negative 2, 3, and 5. And again, all the things I'm doing here is I'm mutating this list that I defined using and called a list. But you don't necessarily have to mutate. And like it's very popular nowadays to do what's called functional programming, and that means you never mutate any of your data. And so you can do that by making copies of your list. Now, a shallow copy is when I just say, new list equals a list. So really what this is doing is it's just setting this variable equal to that variable, and so I have it as it is, and so new list is equal to a list, but they're actually pointing to the same place in memory, which means if I modify one, I'm going to modify the other. So now I've set them equal to each other. And if I change a list and say, let's append 10, and then I'll print new list will actually also have this. And again, we can see this by saying like this, and now I print both of them. Both of the lists are equal, even though I only changed one. So in order to make what's called like a deep copy or an actual copy where it has a new place in memory, I have to say new list is list of a list. And now when I print new list, it's still going to have the same thing, still going to be equal to a list, except if I change a list and then I print both of them, they're going to be different. Because this append is now, because this is a deep copy and they have different places in memory, when I append to a list, I'm not going to update new list. So there are a bunch of other kind of built-in methods that you can do to lists. I mean, you can extend a list. So if I want to say a list.extend, and I can just give it another list, and let's just say like this is 11, 12, 13. Oops. Missing a bracket here, and I print a list. Now the list has 11, 12, and 13, and so you can just easily concatenate two lists. Or I could say a list.reverse, and print a list, and now it's reversed. And these methods, extend and reverse, these are mutating methods, which means that it's just updating the list that's pointed to by the variable a list. But there are other methods that will actually just create a new list. And there are a lot of built-ins and a lot of different things you can do with lists. I mean, like some of them are sorting, filtering, mapping, and a bunch of others. And we're going to see a lot of these later, especially sorting, filtering, and mapping. But for now, that's all we're going to talk about lists, and we're going to move on to tuples. So like lists, tuples are, again, ordered sequence of values. But the primary way in which the two data structures differ is that, unlike lists, tuples are immutable, meaning that, again, the data structure cannot be mutated. So these things that we're doing here can't really happen to tuples, and we'll see that in a second. But it essentially means that once a tuple is created, you cannot add to it, you cannot remove from it, or modify it in any way. So let's see how that looks. So now if I go down to here and I want to create a tuple, so this time I can say a tuple equals empty parentheses. And so that the tuples in Python are represented with parentheses, and whereas lists are brackets. And so now if I print a tuple, an empty one, I just get the empty tuple. And again, if I try and print at a certain index that's not there because it's empty, it's going to throw an error. Oh, sorry, this needs brackets. And it's just going to say tuple index out of range, which is the error we're looking for. But again, like I said, you can't mutate a tuple. So if I actually wanted to try and say like a tuple.append and add the 1 in the same way that we did here with the list, it's going to throw a different kind of error. And that's going to be saying tuple has no attribute append, but the reason it doesn't have that method is because you can't mutate tuples. So in order to have elements in this tuple, I need to have them there when I'm initializing it. So now when I print a tuple, it's going to have these elements, and that's fine. You see 1, 2, 3, 4. But again, I can't remove. So I can't say a tuple.remove 2 because it's not going to have that attribute. What it means, by attribute means method. It does not have this method remove because, again, you can't mutate tuples. But you can still reach values by index, so I can say a tuple of 0, and I should get a 1, and that's what I do. So you can think of tuples as just being sort of like a list, except you can't do any of the mutation that you can do with lists. And you can easily and this has a variety of purposes. I mean, sometimes you just want a data structure that's going to stay exactly as it is, and you don't want to mutate. It allows you to do other things with it, but you can just make a tuple from a list by just saying tuple of a list. So now when I print new tuple, which was constructed using this list and just turning it into a tuple. Oh, sorry. So now I've set new tuple equal to a tuple of a list, and I print a new tuple, and now we have a tuple containing the elements that were in a list at the last time that we modified a list, which is here when we reversed it. So yeah, and you can do this vice versa. So I want to say, new from tuple equals list of new tuple, and then I print from tuple. I'm going to actually get the exact same list as a list, and there we go. Now it's the same thing, but it's back to being a list. So yeah, so they're very related data structures, but they differ in that fundamental way, which has to do with mutation. Lists are mutable, tuples are not mutable, and yeah. And another thing that is important to know about both tuples and lists is that they can contain anything you want. So I can say random stuff is equal to a list containing, 1, and we'll give it like a string, and we'll give it a decimal, or we can even give it a tuple of 1, 2, 3, and that's now this tuple is actually an element in this list. And so when I print random stuff, I have a list containing all this stuff, and I can print the last one, which is at index 3, and it will be the tuple, which is 1, 2, 3. Also, a nice thing about both tuples and lists is that, let's say you don't know what the length of the tuple or list is, but you just want the last element in it, you can always reference that saying -1. So if I print random stuff -1, and if I print a list -1, I'm going to each get their respective last elements. So the last element in a list, as we can see here, is -2, so I get -2. And the last element in random stuff is the tuple 1, 2, 3. Yeah, so that's everything we're going to cover about tuples and lists today. In the next video, we'll see some interesting things you can do with lists when we introduce iteration and loops. But that's all for today, and we'll bring all this together and the concepts we learned so far to make some more interesting functions in the next video. So thanks for watching, and I'll see you next time.